Friends, I give you the CPU, or Central Processing Unit. The CPU, often called the brains of your computer, is really nothing more than a powerful calculator. But man, can it calculate. By making this guy do all that he can do, we can be running around in first-person shooters, or we can be editing video, or we can be writing big Word documents. This is the guy that makes all of this happen. But to appreciate CPUs, we have to appreciate a lot of aspects of it. So let's take a look at a couple of CPUs I've got laying around right now. All right, so what we've got in front of us here are some fairly typical CPUs. I don't even know if you can read those, not that terribly important. But what I have here are the two major manufacturers of CPUs. These are made by a company called AMD, and these are made by a company called Intel. Odds are good you've probably heard of both of them. There are other people who make CPUs, but these two are the big guys. They got 99.9% of the entire CPU market right now. Now, when we're talking about CPUs, we use make and model. So the make would be like Intel or AMD, and then the model would be the number that goes with that. So this is an Intel Core i7-3820, and this is an AMD FX 4100, because that's what it says so on the box. Now, these are very similar processors. They're different sizes. They're physically different sizes, so they have to have their own motherboards. But what's important is I can take either one of these and I can install Windows 7 on a system running either one of these CPUs, and this exact same copy will work for both. That's very important. The reason that is important is because these two CPUs speak the exact same language. So if they're speaking the same language, and they are physically different, so you have to have different motherboards, what's really the big difference other than shape or anything like that? And the big difference comes into how they work on the inside, what we call the microarchitecture. Now, the microarchitecture this is where they spend lots of money and they wear white uniforms and they design these processors and all this type of stuff. And what will happen is that they will be given code names. And once a CPU has a code name, all kinds of interesting stuff takes place. Now, what I'm going to do real quick is I want to fire up my Windows 7 system, and I want to show you a very, very important program called CPU ID. All right, so this program is called CPU ID. It's called CPU Z. It's from a company called CPU ID. Anyway, this is an incredibly powerful program. It's completely free, and every nerd worth their salt has got one of these programs running around. We use them all the time. Now, there's a lot to see here, but at this point, I really want to concentrate right at the very beginning. First of all, we see the name, and you can see that my computer is running an Intel Core i7-3820. But what I want you to see right here is kind of interesting. Here's the code name. This particular CPU is running a microarchitecture called Sandy Bridge. Sandy Bridge is a very cutting-edge microarchitecture, and it has a lot of powerful tools associated with it. It's the microarchitecture that defines a lot of features. For example, is it a 32-bit or 64-bit processor? Is it running 2 cores or 4 cores or 8 cores or just 1 core? What's the speed range? What type of caching does it use? Is there an integrated graphics with that processor or not? So what will happen is once you develop a microarchitecture, then you start making CPUs. One microarchitecture can make a lot of different types of CPUs. So for example, with the Sandy Bridge, we're using these for this Core i7, but it can also be used for Core i5 and i3s. So one microarchitecture is used across a broad cross-section of different CPU models, and that's the important point.